Okay, the chapter dependency chart. So chapters 1 through 6, and then individually 8, 7, 8, and 9 all depend on 1 through 6, but not on each other. You can go 1 through 6 and then 9, 10, 11. After chapter 11, you could skip 7 and 8, and after chapter 11 you could do chapter 12, 13, and 14. You could skip chapter 12, 13, and 14 and go from 11 to chapter 16 and then 17. So 1 through 6, 9, 10, 11, 16, 17. Then after 17, chapters 18, 19, and 20 do not depend on each other. But 18 and 19 stand alone, just like chapters 12, 13, and 14 stood alone after chapter 11. After 17, if you go to 20, you can continue along to 21, 22, and 23. So 23 depends on 22, 21, 20, 17, 16, 11, 10, 9, and 1 through 6. So chapter 23 has the, and also after chapter 11, you could go to chapter 14, and then after 14, go to 15. And those are independent of 16, 17, 20, 21, 22. But I noticed chapter 23 has dashed lines going back to chapters 15, 14, down 11, 10, 9, and then 1 through 6. Also, chapter 23 has a dashed line going back to chapter 13, which depends on chapter 11, 10, 9, and 1 through 6. Chapter 22 has a dashed line going back to chapter 8, which goes back to 1 through 6, and 23 depends on 22. So it seems like chapter 23 depends on everything except 12, 18, and 19. Though there are no specific prerequisites for a course in abstract algebra, students who have had other higher level courses in mathematics will generally be more prepared than those who have not, because they will possess a bit more mathematical sophistication. Occasionally, we shall assume some basic linear algebra. That is, we shall take for granted an elementary knowledge of matrices and determinants. This should present no great problem, since most students taking a course in abstract algebra have been introduced to matrices and determinants elsewhere in their career. If they have not already taken a sophomore or junior level course in linear algebra. Exercise sections are the heart of any mathematics text. An exercise set appears at the end of each chapter. The nature of the exercises ranges over several categories. Computational, conceptual, and theoretical problems are included. A section presenting hints and solutions to many of the exercises appears at the end of the text. Often in the solutions, a proof is only sketched, and it is up to the student to provide the details. The exercises range in difficulty from very easy to very challenging. Many of the more substantial problems require careful thought, so the student should not be discouraged if the solution is not forthcoming after a few minutes of work. There are additional exercises or computer projects at the ends of many of the chapters. The computer projects usually require a knowledge of programming. All of these exercises and projects are more substantial in nature and allow the exploration of new results and theory. SAGE, sagemath.org, sagemath.org, is a free open source software system for advanced mathematics, which is ideal for assisting with the study of abstract algebra. Sage can be used either on your own computer, a local server, or on Colcalc, COCALC.com. Robert Beezer has written a comprehensive introduction to Sage and a selection of relevant exercises that appear at the end of each chapter, including live Sage cells in the web version of the book. All of the Sage code has been subject to automated tests of accuracy. Using the most recent version available at this time, Sage Math version 8.2, released May 5th, 2018. Signed Thomas W. Judson, Nacogdoches, Texas, 2018. The contents: acknowledgments, preface. Then Chapter 1 is preliminaries, a short note on proofs, sets and equivalence relations, exercises, references, and suggested readings. Chapter 2, the integers. That's mathematical induction, the division algorithm, exercises, programming exercises, and references and suggested readings. Chapter 3, groups. Integer equivalence classes and symmetries, definitions and examples, subgroups, exercises, additional exercises, detecting errors, and then references and suggested readings. Chapter 4, cyclic groups, cyclic subgroups, multiplicative group of complex numbers, the method of repeated squares, exercises, programming exercises, references and suggested readings. Chapter 5, permutation groups, definitions and notation, dihedral groups, exercises. Chapter 6, cosets and Lagrange's theorem. So cosets, Lagrange's theorem, Fermat's and Euler's theorems, exercises. Introduction, Chapter 7, Introduction to Cryptography, private key cryptography, public key cryptography, exercises, additional exercises, primality and factoring, references and suggested readings. Chapter 8, Algebraic coding theory, error detecting and correcting codes, linear codes, parity check and generator matrices, efficient decoding, exercises, programming exercises, references and suggested readings. Chapter 9, isomorphisms, definition and examples, direct products, exercises. Chapter 10, normal subgroups and factor groups. So that's factor groups and normal subgroups, the simplicity of the alternating group, exercises. Chapter 11, homomorphisms, group homomorphisms, the isomorphism theorems, exercises, additional exercise. Okay, so Chapter 11 was homomorphisms. Chapter 12, matrix groups and symmetry. So that's matrix groups, symmetry, exercises, and references and suggested readings. Chapter 13, structure of groups. That's finite abelian groups, solvable groups, exercises, programming exercises, references, and suggested readings. Group actions, groups acting on sets, the class equation, Burnside's counting theorem, exercises, programming exercise, and references and suggested reading. That's Chapter 14, group actions. Chapter 15, Scylla theorems, the Scylla theorems, examples and applications, exercises, a project, references, and suggested readings. Chapter 16, Rings. That's rings, integral domains and fields, ring homomorphisms and ideals, maximal and prime ideals, an application to software design, exercises, programming exercise, and references and suggested readings. Chapter 17, Polynomials. Polynomial rings, the division algorithm, irreducible polynomials, exercises, additional exercises, solving the cubic and quartic equations. Integral domains, fields of fractions, factorization in integral domains, exercises, references, and suggested readings. Lattices and Boolean algebras. Lattices, Boolean algebras, the algebra of electric circuits, exercises, programming exercises, references, and suggested readings. Vector spaces, definitions and examples, subspaces, linear independence, exercises, references, and suggested readings. Chapter 21, Fields. So the last one was Chapter 20, Vector spaces. Chapter 21, Fields, extension fields, splitting fields, geometric constructions, exercises, references, and suggested readings. Chapter 22, Finite fields, structure of a finite field, polynomial codes, exercises, additional exercises, error correction for BCH codes, references, and suggested readings. Chapter 23, Galois theory. That's field automorphisms, the fundamental theorem, applications, exercises, references, and suggested readings. The appendices are GNU free documentation license, hints and solutions to selected exercises, and notation. And then last of all, he has an index. So chapter 23 is Galois theory. And in the dependency chart, Galois theory depends on the most stuff. So in many ways, I think we can visualize Galois theory as the goal of a basic abstract algebra course like this, the crowning achievement, so to speak. Thank you.